Math is delicious. Here is Krong Math. How to prove the inequality of arithmetic mean and geometric mean? I am going to introduce the 7 ways to prove it. Actually, a and b is the positive real number including 0. Then, let's get started. Number 1. It is a formal way to prove the inequality. We can define squared a and squared b because a and b are both positive real numbers. The square of squared a minus squared b is greater than 0. Then, we can convert the equation to this form. Squared a squared plus squared b squared minus 2 squared a times squared b equals 2. A plus b minus 2 squared a times squared b. It is also greater than 0. We add 2 squared a times squared b to both sides. 2 squared a times squared b equals to 2 squared a times b. We finally made it. Number 2. We can approach this inequality in a geometric way. There is a semicircle whose diameter is a plus b. The diameter is divided into a line segment a and h, whose length is a, and a line segment bh, whose length is b. From h, we draw a perpendicular to the line segment a and b. It meets the semicircle at c. We connect the dot c and o together to compare the length of line segments ch and co. The length of co is a plus b divided by 2, because it is the radius of the semicircle. The length of ho is the length of ao minus the length of ah, so that it is b minus a divided by 2. Using Pythagoras' theorem, the length of ch equals to squared a times b. Ch equals to squared a times b. Do equals to a plus b divided by 2. Let us move dot h from a to dot o, even if dot h tries its best. The length of ch cannot be larger than the length of do. The optimal point is that when the placement of dot h equals to the placement of dot o. In this case, also the inequality holds. Number 3. This proof is usually called Pauli's proof. Let us think of fx equals to x minus 1 to the power of e minus x. When we think of derivative of fx and second derivative of fx, it is always larger than 0. The graph of fx is like this. You can see that fx is always equal or larger than 0. Plug x to both sides of the inequality. Then x minus 1 to the power of a is equal or larger than x. Let a plus b divided by 2 equals to n. Just place x to the divided by n and place x to the b divided by n. Then, we can represent inequality in these forms. Multiply them, then the left side replaces into 1. Finally, n squared is equal or larger than a times b. N equals 2a plus b divided by 2. We can get into the conclusion. Number 4. Easy approach. Just think of 4 rectangles with 2 sides whose length is a and b, respectively. As shown in the figure, the area of big square is 2 to the power of a plus b. The summation of area of 4 smaller rectangles is 4 times a times b. The area of big rectangle is bigger than the summation of area of 4 small rectangles. We can derive the calculation easily. Number 5. One circle exists, a dot D exists. The center of the circle is a dot O. The tangent line crossing the dot D is represented as the line segment dt. The length of dt is c. Additionally, the line crossing the dot D and dot O meets with circle at a and b. The length of the a is a, and the length of db is b. With easy calculation, the length do is a plus b divided by 2. 2 to the power of c equals to a times b because of the power theorem. Pythagoras' theorem shows that the length of hypotenuse is longer than c. Therefore, the inequality holds. Number 6. This method uses Buffalo way, which puts each variable in a relative way. Let us a is the minimum value of 2 values a and b is the larger value. Therefore, b is represented as a plus u. Of course, each variable is the real number and u squared is equal or larger than 0. We can add a squared plus a times u to the both sides of inequality. Then, we can derive the formula to this form. We just define a plus u to the variable b, so that the inequality holds. Number 7. This is the last one that I want to introduce to you. Here is the graph of function y equals ln x. For ease of explanation, I omitted the x-axis and y-axis in the graph. Everyone knows that y equals ln x is a convex function. Imagine two dots on the function y equals ln x. Those two dots have a and b as the x-coordinate of the dot. We can represent the coordinate of the middle point of two dots as followed. Think of perpendicular to x-axis crossing the middle point. It meets at the point D and the coordinate is represented as followed. Y equals ln x is the convex function, so that the inequality holds. There were 7 proofs of the inequality. I want to show you the observation of the graph to show you the inequality visually. I fixed the variable b to the constant value. In this case, b equals to 1. Then, the graph is shown as followed. I changed the value b to 2, 3, 4, 5, sequentially. You may observe that always arithmetic mean is larger than geometric mean. I hope you all feel and derive each calculation for the proof of the inequality. Thanks for watching my video. If you want to fall into the delicious math videos, please subscribe and press thumbs up button. They would be my driving force to make math videos with the best quality in the world.